this is a short video to work some examples on the previous work, on what we learned, what we mentioned in the previous lesson, on the representation of small and large numbers. Okay, so prepare some pencil and paper to work on, because here you need to do some work. Are you ready? So we can go. First up is standard form. So here you have 7 questions to work out. Write them down, pause the video and try them out. And then we will go through the answers together. Okay? We have some large numbers to start off with, as you can see over here. So we have 762,762,000 and 234.41. Next, you have some small numbers, so that's 0.000098, 4 zeros after the decimal point, and 0.001225. That's the question number 4. And now how about these 3? You've got 22 and 0.2. Try them out. Ready? Okay, so let's have a look at the answers together. Just make sure that you try them out first, okay? Not just peeking around to see the answers. So in the first case we've got 762,000, 762,000. In this case we need to shift the decimal point 5 times. Remember that being a whole number here, the decimal point is not visible, but it is at the end. So we have 5 hops until the decimal point comes behind the number 7. And that will give us 7.62 times 10 to the power of 5. So here now we have another large number, 234.41. So the power of 10 is going to be positive. In this case we need to shift the decimal point 2 times to the left. So that brings us to 2.3441 times 10 to the power of 2. Now we have a small number. Okay, we've got 0.000098. Now in this case we need to shift the decimal point backwards to the right 5 times until it is behind number 9, and that will give us 9.8 times 10 to the power of minus 5. Remember, negative power because we are shifting backwards and because this is a small number. Another small number, 0.001225. In this case we need to shift the decimal point 3 times until it is behind the number 1, and that will give us 1.225 times 10 to the power of minus 3. So now we've got the number 20. In this case we need to shift the decimal point only once until it arrives behind the number 2. Now, as we had said in the previous lesson, ideally you leave this as 2.0, not as only 2, to be properly written down in standard form. Okay, so this will give us 2.0 times 10 to the power of 1, because we needed to move 1 place. Anything to the power of 1 remains the same, so technically you can only write 10 times 10, not times 10 to the power of 1. However, I believe that it helps you not to get confused. Okay, so you can leave it as 10 to the power of 1. Here we have a tricky one. When we have a whole number which is a single digit, and we are asked to write this in standard form. Okay, so number 2, we write it 2.0 times 10 to the power of 0, because in this case we didn't shift the decimal point in any direction, left or right. Okay, and remember from your indices that anything to the power of 0 is 1, so 10 to the power of 0 would be equal to 1. 2 times 1 is 2. Right, so it will be the same. But keep this in mind, that when you have a single digit, which is a whole number, and you are asked to write this in standard form, you need to put the power of 0. last example in this batch is 0.2. In this case we need to shift the decimal point one place backwards, and that will give us 2.0 times 10 to the power of negative 1. Okay, because we shifted backwards and it is a small number. Note that in these three examples the standard form was always 2.0, always started with 2.0. It is the power of 10 which was changing from 1 to 0 to minus 1. Okay, so keep this example in mind. So that was round 1, and now round 2. In the next round we will work in the opposite direction. Okay, I will be giving you 7 numbers which are written in standard form, and you need to write them down in ordinary form. So be ready. First up, we've got these two numbers, 6.23 times 10 to the power of 8 and 2.112 times 10 to the power of 2. Look at the powers here, they are positive. So what does that mean? Are they large or small numbers? Think. Okay? Next we have these two numbers, 8.7 times 10 to the power of minus 4 and 2.25 times 10 to the power of minus 2. Once again, look at the powers. And finally you have these three to try. Okay, 3.0 times 10 to the power of 1, 3.0 times 10 to the power of 0, and 3.0 times 10 to the power of minus 1. Okay, so try them out, pause your video, and then continue once you've finished. Ready? Okay, so let's have a look at what we've done. In the first case we had 6.23 times 10 to the power of 8, so that means that the fact that it is a positive power is going to be a large number. Okay, so as I've told you before, learn to recognize things. So here we have to move the decimal point 8 times to produce a very large number, and that comes to that large number over there, 623 and 6 zeros. Next we have 2.112 times 10 to the power of 2. In this case we have to shift the decimal point 2 times, and that will give us 211.2. Now we have a negative power, which implies again a small number, so we have to shift the other way, we have to shift to the left. Alright, so we have to shift our decimal point 4 times to the left, and that will give us 0.00087. Remember that those hops which are empty, we have to fill them in with extra zeros. (2.25 times 10 to the power of minus 2). Again minus 2, so power negative implies a small number. We shift to the left 2 places, and that gives us 0.0225. Now we have 3.0 times 10 to the power of 1. Okay, in this case we need to shift only 1 place to the right because it's a positive power, so it's going to be a larger number, and this in fact gives us the number 30. Now we have that power of 0. Okay, 3.0 times 10 to the power of 0. And this is easy, because remember, power of 0, we don't do any shifts. So 3.0, the answer is 3. It's just the number 3. And finally, we've got 3.0 times 10 to the power of minus 1. Again, negative power implies a smaller number, so we shift to the left, and that will give us 0.3. Okay? And that was standard form. Okay, so you finished that round, and are you ready for the next round now? What's next? Well, now we just do a small exercise on prefixes. Okay, so again, get ready to write something. Okay, so now you have to expand the following. You've got 6 questions, which are numbers written with prefixes. You have to expand them. Okay, so write them down, try them out yourself before you continue this video. Okay, first we have 6 kilometers, 34 megajoules, 8 gigawatts. And then we also have 5 milliseconds, 3 micrometers, and 7 nanoseconds. So those are your questions. Try them out quickly. Ready? Okay, let's have a look. First up, 6 kilometers. Remember, kilo means times 1000, so that gives us 6000 meters. Next, we have 34 megajoules. Mega means times 1 million, so that gives us 34 million joules. Remember, million, you've got over there 6 zeros. Next, we have 8 gigawatts. Giga is times 1 billion, so that gives us 8 billion watts, which means that over there you've got 9 zeros, 8 and 9 zeros, okay? Now we're looking at the smaller prefixes, okay, the prefixes which represent smaller numbers. Starting off, we had 5 milliseconds. Milli is division by 1000, and that gives us 0.005 seconds. Next one, we are using, remember that symbol mu, which means micro. So we have 3 micrometers, which is division by 1 million. So you've got 0.000003 meters. You would have 5 zeros in this case behind the decimal point and before the number 3. Finally, we have 7 nanoseconds. Nano is division by 1 billion, so again you would have to divide 7 by 1 billion, and that gives us 0.000000007 seconds. Okay, so there you would have 8 zeros behind the decimal point and before the number 7. And you've made it. Well done. Now that wasn't too difficult, was it? Well, as a brief recap, okay, today we had a look at some examples which dealt with writing numbers, small and large numbers. Starting off with examples of standard form and examples of prefixes. You can go over these examples a number of times to help you refresh things, but it will also help to find more examples from your textbooks, to find them online, etc. Okay, as always, practice makes perfect. Okay, thank you for watching and enjoy.